Hi everyone, and welcome to the video going over the activity 16 through 17.2 quiz study guide. In this study guide, we go over graphing inequalities, graphing systems of linear equations, and the substitution method. Let's get started. When you graph linear inequalities, you want to act like you are graphing an equation. So for instance, 5 is my y-intercept. So that is my first point. And my slope, -5/4, tells me I'm going to go down 5 into the right 4. So down 1, 2, 3, 4, 5, and over 4. And then I have to decide if my line is going to be solid or dashed. Since there's no line under my inequality sign, my line is going to be dashed. And then I have to decide which side of my line I am going to shade. Now, because the sign is facing towards the y, this means that y needs to be bigger, and the bigger y values are above the line. Let's try another one. Once again, my y-intercept is 5. And my slope, -9/4, tells me I'm going to go down 9 and to the right 4. So I'm going to go down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and to the right 4. Because I have a line under my inequality sign, my boundary line will be solid. And because the inequality sign is facing away from y, it says that I need to shade below the line. So if your sign is facing towards the y, shade above. And if your sign is facing away from y, shade below the line. Or you can plug in the point 0, 0 and test if 0, 0 is a solution. Let's move on to number 3. In number 3, the inequality is not in slope-intercept form. So the first thing I need to do is rewrite the inequality in slope-intercept form. I am first going to subtract 2x on either side. And then I'm going to divide by the number in front of y. So I'm going to divide everything by -5. And I have to remember, when I divide an inequality by a negative, my sign flips. So don't forget to flip your inequality sign if you multiply or divide by a negative number. -2 and -5, the negatives will cancel out, leaving 2/5x. And then 15 divided by -5 will be -3. So -3 is my y-intercept. And my slope tells me that I'm going to go up 2 and to the right 5. Or I can go down and to the left. Because my inequality has a line under it, my boundary line is solid. And after I flip the sign is facing towards the y, which means that y needs to be greater. So I'm going to shade above the line. In number 4, we also have to rewrite the inequality in slope-intercept form. So let's do that first. I'm going to once again start with moving the x term. So I'm going to subtract 7x to either side. And then I have to divide by the number in front of y. So I'm going to divide by 3 to everything. Because I'm dividing by a +3, I don't have to flip my sign. I'm going to leave -7/3 as a fraction, since they don't divide evenly. and 12 divided by 3 is 4. So 4 is my y-intercept. And my slope of negative 7 over 3 tells me I'm going to go down 7 and to the right 3. I don't have a line under my inequality sign, so my boundary line is going to be dashed. And because my inequality sign is facing the y, this tells me I need to shade above the line. Let's move on. In number 5, it says solve each system by graphing. So I'm going to start with graphing the first equation. My y-intercept is negative 2. And if I don't have a number in front of x, it's assumed to be an imaginary 1. And I can also put an imaginary 1 in the denominator. This tells me that I go down 1 and to the right 1. Or I can go up and to the left. So that's my first equation. For my second equation, I start at 4. And if I put an imaginary 1 under my negative 7, this tells me that I go down 7 and to the right 1. And I can see that the two lines intersect at the point 1, negative 3. And so 1, negative 3 is the solution to this system. Let's try number 6. For my first equation, my y-intercept is 4. And my slope of 3 over 2 tells me I go up 3 and to the right 2. Or I can go down 3 and to the left 2. And for my second equation, I start at negative 3. And my slope tells me that I go down 1 and to the right 4. Or I can go up 1 and to the left 4. And my equations intersect at the point negative 4, negative 2. Remember, it's always x and then y. And this tells me that the point negative 4, negative 2 is the solution to this system. Now let's try some systems that are not written in slope-intercept form. So I'm going to start with rewriting 6x minus y equals 3 in slope-intercept form. I need to subtract 6x on either side. And please be careful, this negative is still attached to the y, and I have to get rid of it by dividing by a negative 1. This will ensure that my y is positive. Negative 6 divided by negative 1 is positive 6. And 3 divided by negative 1 is negative 3. So if I graph this, my y-intercept is at negative 3. My slope is 6 over 1, which tells me I'm going to go up 6 and to the right 1. And it looks like I also have to rewrite my second equation. So my second equation is x plus y equals 4. I'm going to start with subtracting x on either side. And because there's no number in front of y, I am done. I start at the y-intercept 4. And I have an imaginary 1 in front of my x and in the denominator, which tells me I go down 1 and over 1 each time. So down 1 over 1, down 1 over 1, just like so. And it looks like my equations intersect at the point 1, 3. So 1, 3 is my solution. Let's try another example where the equations are not written in slope-intercept form. So starting with x minus y equals -2, I need to subtract x to either side. And then just like in number 7, I have to divide everything by -1 to make my y positive. Negative x divided by -1 will become a positive x, and -2 divided by -1 will become a positive 2. So my y-intercept is 2, and my slope will be 1 over 1, which tells me I go up 1 and over 1 each time. Or I can go down 1 and to the left 1. For my second equation, I have 3x plus y equals -2. I'm going to start with subtracting 3x to either side. And because y is all by itself, then I am done. My y-intercept is -2. And if I put an imaginary 1 under -3, this tells me that I go down 3 and to the right 1. Or I can go up 3 and to the left 1. And my two lines intersect at -1, 1. So graphing the two equations and finding the point of intersection was the first method we talked about for solving systems of linear equations. The next method we talked about was using tables. So in number 9, I need to make a table for each equation. And I know it's tricky when the x values aren't given to you. I would recommend starting with -2, -1, 0, 1, and 2, so that you get a nice even spread of the negative x values and the positive x values. So, looking at y equals -5x plus 1, I know that my y-intercept is 1. So at x equals 0, y is 1. And my slope of -5 tells me that I need to subtract 5 each time. So 1 minus 5 is -4. And -4 minus 5 is -9. And to go backwards, I need to add 5. So 1 plus 5 is 6, and 6 plus 5 is 11. For my other equation, I'm going to use my same x values. My y-intercept is -3, so that's where x is 0. And my slope of -1 tells me I'm going to be subtracting 1 each time. So -3 minus 1 is -4, and -4 minus 1 is -5. And it doesn't even look like I need to finish my table because I already see that they have the point 1, -4 in common. So 1, -4 is the solution to this system. So when we make our tables, we are looking for the point they have in common. Let's try number 10. I'm going to start by setting up my tables. I have y equals 2x plus 3. And y equals -3x minus 2. Let's start once again with testing out -2, -1, 0, 1, and 2. My y-intercept is 3, and so that's the value where x is 0. And my slope of 2 tells me that I'm going to be adding 2 each time. So 3 plus 2 is 5, 5 plus 2 is 7. And to go backwards, I need to subtract 2. So 3 minus 2 is 1, and 1 minus 2 is negative 1. Let's do our second equation. For my second equation, my y-intercept is negative 2. And my slope of negative 3 tells me that I'm going to subtract 3 each time. So negative 2 minus 3 is negative 5. And negative 5 minus 3 is negative 8. And to go backwards, I have to add 3. So negative 2 plus 3 is 1. And 1 plus 3 is 4. And I notice they have the point negative 1, 1 in common, and so that is my solution. So once again, I know tables are tricky. If you are told to make your own table with your own x values, I would start with the x values negative 2 to 2, and then if those don't work, trying an x value in each direction, the positive and the negative directions, until you find one that works. The last method we talked about for solving systems of equations is the substitution method. And with the substitution method, you need one equation to be solved for x or y. So luckily I have the equation that says y equals negative 6x plus 22. And because this equals y, I'm allowed to substitute or plug in negative 6x plus 22 in for y. So I will write 3x minus the negative 6x plus 22 equals 23. So instead of writing minus y, I wrote negative 6x plus 22. And then it's time for me to solve. I have to first distribute this negative. So negative 1 times negative 6x will be a positive 6x. And negative 1 times 22 is a negative 22. I see that I have like terms, 3x and 6x. So together they make 9x. I'm going to add 22 to both sides. And then divide by 9. And I will get x is equal to 5. But I am not done, because in order to find a solution, I need an x value and a y value. And so far, all I know is that x is 5. So in order to find my missing y value, I am going to plug in x equals 5 to either of my equations. It doesn't matter which one I pick. I think I'm going to go ahead and pick the second equation. So the second equation will look like y equals negative 6 times 5, since 5 is x, plus 22. I'll then get negative 6 times 5 is negative 30. And negative 30 plus 22 will be negative 8. So this tells me that my solution is the point 5, negative 8. Let's try this again with number 12. Once again, I have an equation that starts with y equals. So I can go ahead and plug this in for y, which will look like negative 5x plus 2 times negative 8x minus 5 equals negative 10. I then need to distribute, or double rainbow. 2 times negative 8 is negative 16, and 2 times negative 5 is negative 10. I see some like terms that I can combine. So negative 5x and negative 16x together will get me negative 21x. And then I'm going to add 10 to either side. And negative 10 plus 10 will equal 0. And if I divide by negative 21, I get that x is equal to 0. But remember, I am not done because I still need to find y. So I'm going to plug in x equals 0 for the second equation. So I'm going to have negative 8 times 0 minus 5. Negative 8 times 0 is 0, and 0 minus 5 is negative 5. And so together, this tells me that I have the solution 0, negative 5 for this system. I hope this study guide went well and that you are very prepared for the quiz coming up. Please let me know if you have any questions, and I will see you in class.